Hello and welcome back. In this video we'll be looking at compounding interest formulas, and in particular we're going to look at what happens when we compound interest more than just annually. So let's review. If we compound interest annually, this means at the end of the year the interest that we earned gets put back into the account, and then the next year we'll earn a little bit more interest. Because we'll earn interest on the initial principal that we added, but also the little bit of interest that we added back into the account. And there's no reason why this just has to be done at the end of the year. So for instance, maybe halfway through the year, whatever interest we earned gets put back into the account, and since the account has now grown a little bit, we'll earn a little bit extra interest. So there's a few sort of common words that we can associate with this. If we compound interest semi-annually, this means that twice a year, so at the halfway point at the end and then at the end of the year, the interest that we've earned will be added back into the account, so that our account amount grows and we earn a little bit extra interest. We can do this quarterly, so four times a year, every 3 months, we will take whatever interest we've earned, add it back into the account. So now the account balance is a little bit higher, so we will earn even more interest. And then we do this 4 times a year for quarterly. Monthly, that's 12 times a year. Daily, that's 365 times a year. And continuously, meaning every cent that we ever earn in interest immediately gets added back to the account balance, so that it grows and we earn a little bit more. So we'll earn those pennies faster and faster and faster. You can imagine that if we compound annually, we're only adding the interest back once a year. So it's a little bit worse off than if we were to compound the interest semi-annually or quarterly. The more often you compound the interest, the more money there will be, the more interest you'll be earning. So let's do an example. But first we need a formula. And our formula is right here. This is a little bit messy, so hold on, but I will explain where all of these guys come from. So we have the account balance is going to be this guy. And this looks a lot like some of the formulas that we've seen earlier, but it has this extra n in here. So P is going to be how much we initially put into our account. How much are we investing initially? And we'll take P times 1 plus the APR over N. APR is going to be the annual percentage rate, or the interest rate. And then N is going to be how many times per year it's compounded. So for instance, if we are compounding our interest semi-annually, N is going to be 2, because we're going to do it 2 times a year. If we're going to compound interest daily, that means that it's going to happen 365 times a year. So N would be 365. And then Y is just the how long are we going to invest it for in years. And there is a separate formula for interest that is being compounded continuously. So when we're compounding interest continually, every cent that we ever earned immediately gets added back to our account. It's a little bit different formula. And here we see this funny E popping up. And E is just a number. If you plug it into a calculator, a scientific calculator will have it pre-programmed in, so you don't have to know what E is. But it's close to 2.7. I think it's 2.718 something. It's kind of like pi in the sense that it's a number that comes up so often we gave it a name. So let's use our 2 formulas to find some interest. So we're going to invest $1,000 for 10 years at an annual percentage rate of 5%. So let's find the account balance if it is compounded. We'll do annually, semi-annually, we'll look at quarterly, monthly, daily, and continuously. So let's do an example of each. So first and foremost, our initial principal, the amount that we're investing, is $1,000. We're investing it for 10 years, and our annual percentage rate is 5%, but we want this as a decimal. We want this as an actual number, not as a percentage. So I'll take 5 and divide it by 100 to get 0.05. So we have all the numbers that we need for our formula, except for n, and n is how many times a year is going to be compounded. So let's look at this first one. So if we compound interest annually, how many times a year are we compounding interest? Well, annually means once a year. So here n is just going to be equal to 1. So if I take, so my formula is going to be, my account is our principal, 1 times 1 plus our APR, oops, I can't spell today, APR divided by n, raised to the n times y power. So again, our principal is going to be 1,000. This is how much we're investing. And we're going to take this times 1 plus our annual percentage rate, which happens to be 5%, but written as a number is going to be 0.05. And how many times a year are we going to compound this? Once. And we're going to raise this to the 1 times 10 power. So this is our formula, and I'll show you how to put this into decimals. So we're going to have 1,000 times, and then I'll add my parentheses. So it's going to be 1 plus, we're going to have a fraction. On the top of the fraction, it was 0.05. Bottom of the fraction, how many times are we compounding it annually? That's just 1. Let's add our parenthesis. And then I need to raise this to a power. And I'm going to show you what goes wrong if I make a mistake here. If I take 1 times 10, well, the times 10, for the 10 years that we're investing it, comes down outside of the exponent. I want it 1 times 10 all the way up in that exponent. So what I'll do is I'll add some parentheses. So I'll take 1 times 10, and now our formula looks correct. So at the end of 10 years, rounding to the nearest penny, we will have $1,628.89. We won't round up with the 4 there. So 1,628.89. 628.89. So this is how much money there will be in the account after 10 years if we compound it annually. So let's see what happens if we compound it semi-annually. So semi-annually means that we're going to compound this twice a year. So n here is going to be 2. So halfway through the year, we'll take whatever interest we have, throw it back in. And then at the end of the year, we'll take what interest we have and we'll throw it back in. So the money in the account, I have our formula right here. It's going to be $1,000 initially times 1 plus our percentage rate, written as a number, divided by n, which here is going to be 2, and we're going to raise this to the 2 times 10th power. So let's figure this out. The nice thing about Desmos is that here was my answer before. I can go back in and I can change. Instead of compounding this once a year, I'm going to compound this twice a year. And we see here that we have $1,638.62. We'll have to round up because there's a 6 there. So 38.62. So if we compound this annually and compound this semi-annually, if we add our interest back in sooner, that means that that interest will start earning interest. So we earn a little bit more. In this case, about $10 more if we compound this semi-annually versus annually. Let's do this quarterly. So if we're compounding this quarterly, that means 4 times a year. We're going to add our interest back in. And again, we can take our account balance is going to be our initial principal times 1 plus our APR, which is 0.05, divided by how many times a year are we going to compound this. We're going to raise it to the 4 times 10th power. So we come back to Desmos, and we are going to compound this 4 times a year now. And we get 1643.62. Again, rounding this to the nearest penny, the 9 is going to round that up. 1642.62. Did I get that correct? 1643, in fact. So we earned a little bit more money by compounding it quarterly. Let's look at this monthly, daily, and continuously. So again, monthly, how many times a year are we going to compound this? Well, once a month, that's 12 times a year. So again, our account balance is going to be our principal times 1 plus our APR divided by how many times, our APR we know was 5%, so that's 0.05. And how many times are we going to do this a year is going to be 12. And we're going to raise this to the 12 times 10th power. And here, we can come back and we'll change the 4 to a 12. And we get 1647.01 after I round this. So again, we're earning a little bit more money by doing this monthly. If we do this daily, well, there are 365 days in a year. So our account balance is going to be our principal times 1 plus our APR divided by how many times a year are we going to be compounding this, raised to the, well, how many times a year are we compounding this times the number of years that we're doing this. So we're changing 12 to 365, and we get 1648.66. So we can see that the difference between compounding something monthly and daily, sure, compounding something daily is going to be a little bit more than monthly, but not a whole lot more. And then finally, continuously. And continuously had its own formula for this, because we can't say we're doing this infinitely many times during the course of a year. Infinity isn't a number. I have nothing to plug in there. So our formula is P times E to the APR times Y. So again, P, our principal, is going to be 1,000. E is just some number that our calculator notes. Our APR is going to be 0.05. And the number of years that we're investing is 10. So if we come back, I can take 1,000 times, and if I just press E on my keyboard, it turns up. And then I can raise this to the, I need my parentheses, my APR, which is 0.05, times how many years are we investing. And here we get 1648.72. And we can see that the difference between investing daily, or compounding daily, and compounding continuously isn't very much.